Now we will discuss the next theorem, that is quotient rule, that is known as quotient rule. That how to find the derivative of a function of the type this. So the theorem says that the derivative of such functions can be found in a way squared of the function that is in the denominator, then the rate of change of the first function, and the function in the denominator as it is, minus the rate of change of the function in the denominator and the function in the numerator as it is. So this is what the quotient rule says. The rate of change of the function that in f of x over g of x is written as the squared function, the square of the function in the denominator, the rate of change of the function in the numerator, the function as it is in the denominator minus the rate of change of the function in the denominator, and then its product with the function in the numerator. We will prove it by using the definition of derivative. But there is an interesting thing about its proof, that it can be proved by using the definition as we did earlier, by proving all the 5 basic theorems using the definition. But we can also prove this theorem by using the previous theorems. So this is the really interesting thing about the proving of this theorem. So I will prove this by using the 5 previous theorems. So let's see how we can do it. So now the function is f of f over g of x. So we can also see it in a slightly different angle. That f of x is a function and 1 over gx is another function. So there is a product of 2 functions. So we can use the product rule to prove this. That is d by dx of the function. By using the product rule, we can say the rate of change of the first function, then the second function as it is, plus the first function as it is, and the rate of change of the second function. Now d by dx of 1 over gx, here we can use the power rule. How? If we can only find the rate of change of 1 over g of x, so we can write it g of x to the power minus 1 d by dx. So by applying the power rule, power comes down, g by g of x, there should be decrease in the power, and then the change of the function, then we will multiply it d g of x over dx. So this it will be minus 1 g of x minus 2 g dash of x, also written as minus g dash of x over g of x squared. So this is the final term of this derivative. So we can just put this value in this at this position, and let's see what we get. Now taking LCM in a simple way that we did. So g of x whole squared, Here we get f dash of x g of x minus f of x g dash of x. And what it is, it just what the quotient rule says about such type of functions, that how we can find the derivative of such functions. And so we'll prove it by using the previous theorems that we proved earlier. So this is an interesting thing about the proof of this theorem, and we can also prove this by using the definition of, or we can use the first principle to prove it. But this is the more interesting way to prove the quotient rule. Let's see an example. If the function is a plus x over a minus x, so we can find the rate of change of the function by using the quotient rule. So the quotient rule is the square of the function in the denominator, then the rate of change of the function in the numerator, the product with the function in the denominator, minus the function in the numerator as it is, and then the rate of change of the function in the denominator. Here a is a constant, that it doesn't depend upon x, so d by dx of a plus d by dx of x, a minus x as it is, then a plus x d by dx of a minus d by dx of x, and then whole divided by a minus x whole square. So a is a constant function, so the rate of change of the constant function is 0. This dx by dx is 1. Here is also 0, and we get here 1. So it is 0 plus 1, 1, and a minus x minus, this is negative, and 0 minus 1, negative 1, positive a plus x, and whole divided by a minus x whole square. So a minus x plus a plus x, this and this will cancel out with each other, and a plus a is 2a over a minus x squared. So this is our final answer, that rate of change of y is equal to 2a over a minus x whole square. So this is how to use the quotient rule in order to find the derivative of such type of functions. So there are 6 basic theorems. The first is about constant, the second is about the power rule, third is about the product of the constant with the function, the fourth is about the sum and the subtraction rule, the fifth is about the product of the two functions, and the sixth is about the quotient rule. So stay tuned, and we will meet in the upcoming videos. Take care. Goodbye.